Welcome to today's webinar with the title Digital Standard Stackups. We are speaking your language. I am Andreas Schirp. I've been working for Würth Elektronik for almost 30 years, and I'm also the speaker of the webinar today. Now let's have a look at the agenda. I will talk about standards in general and the power of standards. And I will show what I call the new way how to find a suitable stackup. Then I will show you all the predefined standards, the digital standards for our technologies. We will see a demonstration video how this works step by step in Altium Designer 20, and I will talk about possible modifications of these standards, and finally giving a summary and an outlook. So standards, what we see here is a picture of the DIN Museum, and one of the most well-known standards is that of the A series of paper sizes. You see that in the picture on the left top area where we see a DIN A4 paper format. And we all love this standard and use that every day. And this standard was already recognized and published in the year 1922. So a standard is something that is regarded as exemplary, model-like, and by which others are guided. So a guideline, a standard. And we also are using standards at work. So especially in our business, we know the IPC standards pretty good. We also using UL standards and a lot of more standards, of course. And for the PCB designers, it's important to get even more information about materials, about stackups, about design rules. But unfortunately, there are only a few standards in the business marketing in the market, and they are mainly offered as paper or, of course, as PDFs. So we use standards all the time, but when it comes to designing PCBs, so we let the variety of options tempt us into daily misunderstood creativity. And in my eyes, this is dangerous and expensive at the same time. On the other hand, paper is a thing of the past. So now we can offer you PCB standards for a lot of EDA tools, and this makes the thing much more easier. Standards at work are the basis for quality and efficiency and reliability. So reliability by using proven stackups, and behind these proven stackups, we have proven manufacturability, high yields, yes, and last but not least, cost optimized. And in the digital form, standards are unbeatable in terms of error prevention and productivity increase. So start by the click of a button with your stackup. That's the message today. So here we can see a principal PCB design flow. I've divided that flow into 4 parts: mechanical design, physical design, EDA layout, and documentation. And I've highlighted in red all stack-up related items. Regarding the mechanical design, especially if you want to use flex or flex rigid technology, depending on the installation concept and maybe foldings, the bending radius has a high impact on the stack up, of course, as well as the IPC use, whether it's flex to install or maybe even continuous bending. Regarding the physical design, of course, there is a dependency on the material selection. So what are your operation conditions, your operating profile? Next is thickness, of course, and again, thickness of the flex means which bending radius ratio do we have, the number of copper layers, which kind of wire technology do you need to connect your components, the functional surface depending on the assembly and soldering technology, impedance matching. Then regarding the layout itself, of course, you need a stack up to fill up your layer stack manager to define and specify wire types, make your impedance profiles if necessary, and of course also design rules. And regarding the fabrication data, of course you have to document your material and stack up, and as well the functional surface. So a lot of important things based on stack ups. So this picture is experience we still have, and I call that the old way. And what does that mean? So behind the wall, that's you. And we're getting a parcel thrown over the wall. That means that's still common to make a PCB layout and copy and paste specifications from older projects, also materials and stack ups. So if this was a successful development, it's not totally wrong to use the old specifications again if they fit to the new project. So the layout process is finished, completed, and typically the next step is to go to the purchasing department and to try a PCB manufacturer who makes the boards, at least in prototype volume. The next point is an interesting one. What about the series? What about the yield, the reliability, and the cost? You remember the words in the beginning of the webinar when I talked about usage of standards and the power of standards. So this is what I call the old way, and in a certain part it's dangerous, and the more complex the technology, the less this one-way street works. So what could you do? Cooperate with your PCB manufacturer. So first specify your load profile of your project, of your application, and therefore out the material requirements, and check then in the second part whether you could use a standard stack up wherever possible. So this makes the thing much more easier. If there is no standard fitting your requirements, of course you can talk to your PCB manufacturer and start a project if this is needed. So if it's not a standard you can start a project with us. So the message is use standards and use the standards in digital form if possible. This is a new and better way to efficiently develop quality in every new project. The times when standards had to be transferred from paper or copied from old projects are now over. Let me give you some remarks and explanations to prepare the following standard presentations. So the nomenclature of the file names, they are really important. As you can see, in the first place, in the name, you can see the kind of technology. So this is basic technology. The second example is flex technology. A third one is HDI, high density interconnect technology. Behind the technology, followed by the total layer count. So all the three examples have 6 copper layers in the stackup. And at third place, we can see the construction. So the first one is a multi-layer with 6 layers in total. The second flex example is a flex rigid. So we have 2 flex layers outside and 4 rigid layers, 6 layers in total. So we can see the construction here. And as well here in the HDI example, we have a 1-4B1 construction. So the next part of the name shows us the true overall thickness. So this is what we have calculated based on the specified standard, the stackup. So we have, for example, 207 millimeters, 103 millimeters, and 136 millimeters for the third example. The last number shows the thickness, the nominal copper thickness of the inner layers. And so this is a 1 ounce copper weight inner layer foil, sardine foil, again 1/2 ounce and a 1 ounce 35 micron on the inner layers. Now let's see how this looks like in the tables I will show you. This is an excerpt out of the basic technology we will see afterwards. And again, you can find different columns. You can see the number of copper layers here. And there is a column called nominal thickness. This is just for your orientation. So if you're looking for a 2 millimeter board, for example, so this is your orientation, and then you can see which real and true overall thicknesses you get. So this will end up in a thickness of 2.14 millimeter based on the stackup, and with 1 ounce inner layers, we will even have 2.18 millimeter. So this is a real thickness without a tolerance. So you have to calculate plus minus 10% tolerance in this on this value. Okay. So now let's have a look at the basic technology. So basic technology are multi-layers with bladed through holes, no microwires, no buried wires, no flex material, so just basic technology. And we have 2 columns, one with 17 micron copper and the other one with 35 micron copper on the inner layers, as already mentioned. You may miss the value for the TG here. So what we have done is we already decided to follow our base material recommendation, and there are some standards based on TG 135 degree C material, and the thicker ones and the high layer count ones, according to our base material recommendation, will be based on TG 150 degree C. So this is a mix in the table. These are the standards we have specified. In the or behind the red box, there is also a link. So if you have the presentation afterwards, you can follow the link directly out of the presentation. So these are the basic stackups for basic technology. Now I want to have a poll, and the question is, do you also document the soldering surface, for example, nickel gold, hot air leveling, and so on in the stackup? I will now start the poll and ask you to give the question, you should now see the blue window with the two possibilities, yes or no. And we have 30% participation already. And I'm really excited about the result, whether it's comparable to the result in the German session or whether it's different in the English-speaking world. It looks like it's slightly different to the German session. And we actually have 60% participation. I will wait a few more seconds. I would like to have 70% or even more to have a good statistics behind. So by the way, we have nearly 100 participants today in this webinar. So this is good news. So we have 71%, and obviously there's no one other willing. Some new answers. So I will now close the poll and show the result. So in this session, we have 65% with yes, you document your soldering surface in the stackup, and 35% do not document the soldering surface in the stackup. So this helps to decide about the further proceedings with these digital stackups. And so it looks like I should add the soldering surface also in our standards, which is not the fact today. So by the way, in the German session, it was half and half. So the English guys seem to be better in documentation. So thank you very much. Getting back to the presentation, we will have a look on the standard stackups for the HDI technology. So to prepare this, we have to have a look at the different stackup variations which are possible in HDI technology and in our standards we have created. So what's most easy is, of course, one microwire layer on the outer layers with plated through holes in combination, or having two microwire layers or 3 microwire layers. So by adding buried wires, it becomes even more complicated. So this is the option for having a microwire layer on the outer layers and a plated through hole, which is obligate, and a buried wire inside. If we have 2 microwire layers, we could have 2 options, and here you can see the buried wire starting at layer 3, and on the right side the buried wire starting on layer 2. So in the comparison of these 2 stackups, we can state that in this case, if we start on layer 3, we have 1 more lamination step compared to the other one, and even 1 more plating process. So this one on the right side is more cost efficient. So if you can use this one, please use that. And the same thing for 3 microwire layers. Again, we have on the left side, if the buried wire starts at layer 4, we have 1 more plating process compared to the case if the buried wire starts on layer 3. So this was just to explain the different wire combinations you also will see in the table now. So this is the table for the 1 ounce copper weight on the inner layers. We also have a table on our web with 1/2 ounce copper on inner layers. So we can go for that and download that also. So what we see here is all the standard for HDI. Again, we have the different columns, the number of copper layers, the nominal thickness for your orientation, And then we've got a lot of different construction variations. As I already explained, we have the 8 different constructions here, and in the columns you can find the different standards which are available here. And by the way, if you are on our internet website, so you can then click on the red data name, and then you can see either the PDF stack up or download the fitting EDA data to import that into your EDA software. Next technology we see is SLIM.flex technology. We cared for that technology in one of our last webinars. So if you need more information about that, please look into our webinar archive on our website. Here we've got 3 standards, 4, 6, or 8 copper layers. And by the way, it's always the same stack up physically if you have 2 layer, 4, or even 6 layer in the flex area here. So we have 8 layers in the so-called rigid or thick part, and we can choose whether we are using 2, 3, of course, 4, or 6 layers in the flexible area. So physically it's the same stack up here. And last but not least, let's have a look on the rigid flex table. Again, we have different constructions, different variants. We show 4 of them here, where we have standard as well. And we have the 1F XRI, so that means 1 flexible layer outside. Third one is with 2 flexible layers also outside, and now we have flex inside with 2F, as you can see in the construction nomenclature, and we have another standard for 4 layers inside. So I have added some more explanations regarding the nomenclature of flex rigid. You can go into detail if you are interested. Okay, so that's the preparation for the table. Now let's have a look at the table. And now we have 2 up to 10 layers this time. So of course we can also have a 2-layer construction, which could be a 1F1RI, for example. We have 3 layers. If we have, for example, 2 flex outside and 1 layer on the rigid, and we have a lot of other different constructions. If we have 4-layer flex inside, the minimum total layer count is 6, of course. So next thing is that I want to show you a demonstration video, and now I will start this.
Hello and a very warm welcome to this video. My name is Sven Ingelfinger, and today we want to talk about layer stack up templates. I will show you a method how you can easily add layer stack up templates to your projects by simply clicking your mouse button. So I have currently opened the Altium Designer, and as you can see I've opened the PCB document, and we will have to navigate to the layer stack up manager for this. So simple, click the design menu at the top bar, and from there you can open the layer stack manager. As you can see, I have a very simple default stack up in this project. It's a 2-layer board, and we will now add a layer stack up template. Just navigate to the website of Würth Elektronik. Würth Elektronik is a very big PCB manufacturer from Germany. They have specialized in several products like RIGID.flex designs or multi-layer boards, stack ups, and also SLIM.flex designs. Navigate to the menu multi-layer. There you get the category stack ups, and from there you can download several templates for stackups for typical EDA tools. We will choose the layer stackup Altium category. As you can see, there's a complete list of stackup templates available. They are categorized by their layer numbers, 4, 6, 8 to 10 layers in the standard stackups, and you have an overview about the nominal thickness of the board. Also about the copper finish, in this example 17 micrometers copper and 35 micrometers of copper. We will use for the tutorial an 8-layer board with 1.55 millimeters, and we will only simply download this file. Basic 8 ml 1.55 17 micrometers copper finish. Just download the file, and after that navigate back to the Altium Designer, and from there you can easily add this template to your PCB project by clicking the File menu and select the command Load from File. From there you can navigate to your downloaded stackup, and when you open it, all the layers which are predefined in this stackup are now available in your layer stack manager. You can now easily edit them. You can change the names, for example like this. And after you have edited, you can save it, and when it's saved, it's available in your PCB document. To do a double check, simply click the L button on your keyboard, and the View Configurations panel in the Altium Designer will open. And here you can see the layers are now in the correct order. They are all available right now and have the correct names like we edited them before. You also get information about wire types, which are predefined in the stackups. In this stackup, there are only through-hole wires available or recommended, and in several other stackups there are also micro wires or blind wires. It depends on the manufacturing process, but you don't have to care about this. It's predefined in the templates. When we go back to the website of Würth Elektronik, you see there are also other categories available. For example, the Flex Rigid category, where you find also stackups for the Altium Designer, which you can download from the website. There's also a cool option for all the Concord Pro users, maybe in this audience, and I will show you a trick how you can add such a template to your Concord Pro server. Just open the panel Explorer to get a view into your server, and from there, as you can see, there's my personal Concord Pro installation in this Explorer panel. I have a category or folder, it's called Templates, and underneath there's a layer stackup folder. Currently the folder is empty, so I want to show you how you can now add an item, an PCB stackup item to your to this folder, and how to add a template which we have downloaded from the website from Würth Elektronik. Just click on the button Add an item, and from there you can upload a template file, and we will navigate to it like we did it before, Downloads, and choose the stackup. I will copy the name because I think the naming scheme from Würth Elektronik is pretty cool, and under the Advanced tab you can give this item a name, and I will call it identically like the naming scheme from the stackup, and I will give several other informations to it. A release note and a little description. Something like this. By hitting the OK button, the file will be uploaded to our server, and we see nothing right now. We have to click the refresh button, and after that the template is now available on the server. And as you can see, there's also a preview right here in this window, where you can see a little information, a little bit of the stackup, some parameters, and also you can see the wire types, or maybe if you have the impedance profiles. So now, how can we use this in our PCB document? We have to open the Design Layer Stack Manager again, and from there you could now easily click the File menu, and from there you have to choose the command Load from Server. in this case, the Concord Pro interface pops up, and from there you can select which stackup you want. We've only this one, so I will load this one, and as you can see, it's pretty the same idea of how you get a stackup to your design. In this case, it's pretty cool because you can save all the templates in your Concord Pro workspace and use them in all your designs which you want to. So to sum this up a little bit, it's pretty cool what Würth Elektronik has developed right here. All the stackups are available on the website, all stackups for their standard products, and you could easily download them, use them in your projects, and you can be sure that they can be produced. You don't have to fine-tune your personal stackups and collaborate with the manufacturer. They are predefined and can use them, and as you see, it's really, really simple. Thanks for watching. I hope this video was helpful, and we see you in the next tutorial. Bye bye. This is Sven.
Okay, so this was the demonstration video, and let's come to where you can find all these digital standard stackups. So we have a short link you can see here. I also created a QR code if you want to have it to see a short look with your smartphone. And next interesting thing is which technologies and which softwares we support today. And we have seen all the technologies: basic, flex, rigid, SLIM.flex, and micro via HDI. And today we could provide that for Altium Designer 20, for Cadence regarding basic and flex rigid, as well as IPC 2581 data format for basic and flex rigid, and the last two, Cadence and IPC data format, will be provided also for HDI, microwire, and SLIM.flex in the next weeks. All of them are available as PDF, of course. So that's paper, but we want to lose the paper. We also plan to offer this for more technologies. They will follow this year, and as well for other EDA tools. For example, we are thinking about Mentor, Eagle. So it's interesting what you want to have, and if you have any wishes, please let us know, maybe via email or in the question window. There are also the possibility of modifications and of project-specific stackups, and so all the standards could be also modified, for example, changing material thickness or creating different wire technology. So, for example, adding micro wires where possible, of course. That's perfect if you do that based off our material database. So I will come to that point in a minute. What I want to show you is one of a kind of problem which could occur. So this is one example from one of our customers based on our standards. He tried to change the wire technology. Unfortunately, now we have 20 micron copper on inner layers as well as 20 micron thickness of the solder mask. And this comes from the precision of his preferences. I will show that immediately. So this is a basic recommendation. Please do your data output with 3 digits behind the decimal point. And in Altium Designer 20, this could be done in the properties panel. If you are in Draftsman, double click on the stackup and then change the value precision in the properties panel, as you can see here with the red mark. So if you do that, you will end up in a better documentation as we have it in our standards. You can see here we have 70 micron copper, and we have 15 micron solder mask thickness. So this is more precisely and removes problems. Few words on the material database we are providing for Altium Designer 20, revision 20. And first of all, there is some data in Altium Designer already from Altium. So for some materials as well as some solder surfaces. On top of that, we specified different material classes, prepregs, cores, copper foil, solder mask, and coverlays, especially for flex rigid technology and flex technology. So based on this database, one advantage is you can only choose available materials, and you get all the material specs and dielectric values. So dielectric constant and loss factor are already included in the database. And for adding functional data, functional surface, please use the predefined Altium data. Actually, we are providing a revision 2.12. We published that yesterday. So if you are asking for material database, you will get revision 2.12. And we have decided to have our own webinar on this specific topic at short notice. So we'll have another webinar regarding material database in Altium Designer 20 on the 23rd of February. So please think about participating again. And now let's have a short summary and as well an outlook, what we'll do in the next time. So digital standard stackups are available in proprietary data format for several EDA tools. I've shown that in the presentation. More technologies and more EDA tools will follow based on the need. And the next step we are doing is updating all of our standards on the base of the new MATLAB revision 2.12, and this is planned for next week. And in the future, we will also offer rule sets for Altium Designer. Firstly, so we will have templates with a combination of stackup and fitting rule set for that. And we expect that for the third quarter of this year. Advanced templates will also follow, and as well other EDA tools will follow this way. So if you want to collaborate with us for having other EDA tools, you are welcome. Please write in the question box or send me an email. And if you are interested in general in participating in our circuit board technology webinars, please register for our newsletter. So we inform you via newsletter every time if we are doing a new webinar. So this brings us to the end of the presentation. I want to thank you very much for your participation and for your attention.